Hola, mis estudiantes. We're going to look at the morning work for April 20th through the 24th. So number 1 says write the following number in standard form. And they've given you the number in expanded form. So for standard form, we just want only the digits as we would read it if we were just looking at a number, usually on a piece of paper. So I have a 2 in my 100,000s place. You could think of it as each place. Sometimes I do it that way. Okay, so I have a 2 in the 100,000s place. 60,000, that means it's the digit 6 is in the 10,000s place. I have a 3 in the thousands place. I have a 5 in the hundreds place. I have an 8 in the ones place. Okay, which means I need a placeholder for the tens place. And then my 7 is in the hundredths place. So again, I need a placeholder in the tenths place. I could put a placeholder in the thousandths place as well, but it's not necessary. It's not going to change the value. So I have 263,508 and 7 hundredths for Monday number 1. Monday number 2 says Morel bought 6 ounces of aged cheddar cheese to the family reunion picnic. She will share the cheese equally with everybody at the picnic. If each person, including Morel, gets 1/4 ounce of aged cheddar cheese, how many people are at the picnic? Okay, so I wanted to look at this with a picture first. So she brought 6 ounces of aged cheddar cheese, and so each of my circles represents an ounce of cheese. We don't know how many people are at the picnic. That's what we're trying to figure out. But every single person is going to eat 1/4 ounce. So I'm going to take each ounce and I'm going to split it into 4 pieces or fourths. And it says that every single person ate a piece, including Morel. And so we basically just need to see how many fourths there are to see how many people there are. So I have 4 fourths here, plus 4, plus 4, plus 4, plus 4, plus 4, or 4 times 6 is 24. So be careful if you had a fraction or a mixed number kind of answer, because you could probably see that that didn't make any sense because the question says how many people are at the picnic. We're hopefully not going to have 3/4 of a person usually. So 24 makes sense. If you want to look at this with just numbers and just an algorithm, what we're doing is we're dividing. So we're taking 6 ounces of cheese and we're splitting it into pieces the size of 1/4. Okay, or we're taking 6 wholes and breaking that into fourths. And so remember, when you do division with fractions, you're going to use keep, change, flip. So I'm going to keep this the same. I'm going to put a 1 under it just to make it a fraction. This is going to change to multiplication, and then this is going to flip to 4/1. And then 6 times 4 is 24, and 1 times 1 is 1. And 24 divided by 1, remember fraction bar means to divide, 24 divided by 1 is 24. So you get the same answer either way. Always picture what your problem is asking, especially with fractions. That usually helps a lot. Okay, Tuesday number 1, we just have a division problem with a decimal. So remember that I have to have a happy whole number divisor. Well, I've already got a whole number, so I don't need to move the decimal to the left or the right. I don't need to multiply or divide by a power of 10. Okay, so I can bring that decimal straight up into the quotient, from the dividend to the quotient. And then I'm just going to divide. So if I have 5, I can't pull out a group of 8. If I have 55, I can pull out a group of 8. I know that 8 times 7 is 56. It's just 1 too big. So I know that 8 times 6 will work, and 8 times 6 is 48. Okay, I subtract and I should get 7, and then I bring down my 6. 8 goes into 76. I know that 8 times 9 is 72. 8 times 10 would be too big, of course, that would be 80. So I get 72, and then I subtract, and I have 4, and then I'm going to bring down this last digit. Okay, 8 goes into 41 5 times. 8 times 5 is 40. I subtract and I get 1. Now, back in the olden days, before you were in 5th grade, you would probably stop here and then just put remainder 1. And that's okay, but if we want to make the problem super precise and specific, we can actually keep going. And sometimes we've talked about, sometimes it's not going to work out evenly. The number might keep going on and on and on. Sometimes it will. This is one where it will work out if we just keep going a few more steps. So I'm going to add a 0. I would normally add a decimal 0 if this was a whole number, but since I already have the decimal, I'm just going to add the 0. It's not changing the value of this. It's not making this greater or smaller. It's the same amount, okay? And then I'm going to bring down my 0. And 8 goes into 10 once. 8 times 1 is 8. Hopefully you can see that. I subtract and I get 2. So I'm going to bring down another 0. 8 goes into 20 twice. 8 times 2 is 16. I get 4 left over. And then if I bring down one more 0, 8 goes into 40 5 times. And 8 times 5 is 40, so there's no remainder. Okay, so this is actually going to be your final answer. Okay. Tuesday number 2 says, Tuesday number 2 says, I think I forgot to write that one on my paper. Let me go to a new page. All right, Tuesday number 2. Janice wants to break 28 50 hundredths or 5/10 or 1/2 pounds of cookie dough into tubs of 7.5 pounds each for her bakery. How many tubs will she need? So this is just like the last one. We're actually dividing. She has a total of 28 50 hundredths pounds of cookie dough, and she's going to split those into tubs of 7.5 pounds. And we want to know how many tubs she's going to need. That's what our question is asking. That's going to be our quotient. Okay, I don't have a happy whole number divisor yet, so I need to make it that way, which means I'm going to multiply by 10, or I'm going to move the decimal one place to the right. And so now I have 75 just as a whole number. And then whatever I do to the divisor, I'm going to also do to the dividend. So I'm going to move my decimal one place to the right. Okay, and that would be 285 and 0/10, but that's really, I don't need that 0 or that decimal. So I just have 285. Okay, and then I can divide. So I know 75 won't go into 2 or 28. I'm trying to see how many times it will go into 285. So if I think of 3/4 as 75 cents, if I added 3 more quarters, I would have $1.50 or 150 cents. So I know that twice, I might have said it wrong, but yeah, 2 groups of 75 is 150. So I know it's going to be more than 2. And if you keep going and experimenting, you'll see that 3 is actually the number of times that you can divide. Okay, so then 3 times 5 is 15. 3 times 7 is 21, plus 1 is 22. And then I'm going to subtract. So I get 0, 6, and then 0. So just like the last problem, I'm going to add a decimal this time and a 0. And I'm going to bring this 0 down. And then 75 will go into 600 8 times. Okay, and then 8 times 5 is 40. 8 times 7 is 56, 57, 58, 59, 60. Okay, so she's going to need 3 8/10 tubs to contain her cookie dough. But you're not typically going to find an eighth of a tub or an eighth of a container, or 8/10. Sorry, not an eighth, but 8/10 of a container. So the next part of the question says, if you round this quotient to the nearest whole number, since the decimal part would require a whole other tub, how many tubs will she use? So she doesn't want any left over, so instead of 8/10 of a tub, she's just going to need to go ahead and use 4 tubs to fit everything. That means there will be space left over for more cookie dough in that last tub. Okay, so now we're on Wednesday. Wednesday number 1 says John eats 1/16 of a chocolate cake right after his sister Gina eats 5/16 of the cake. how much of the cake is left. So you can use a picture to solve this. You can use just the numbers and an expression, and we'll look at that in a second. But I do want you to think about picturing everything, like I said, especially with fractions. So I have 16 pieces here. This is my cake. It's been split into 16ths. Okay, so it says John eats 1/16, but that's after his sister has already eaten 5/16. So then I'm just going to add 5 more 16ths for Gina. Be careful. I feel like a common mistake with this problem could just be misreading the question. It's not asking how much of the cake has been eaten. That would be 6/16. But my question actually says how much of the cake is left. So be careful. I bet that's what got some of you if you missed that one. Okay, so I have 2, 4, 6, 8, 10. I have 10/16 left over. And then if you simplify, remember that just means I'm going to divide or multiply. But if I'm simplifying, I'm going to divide the numerator and denominator by the same thing. You can multiply to find an equivalent fraction, but to simplify, I want to divide. So since both numbers are even, I know that I can divide by 2. And then 10 divided by 2 is 5, and 16 divided by 2 is 8. So 5/8 of the cake is left over. If you looked at that just with numbers and not with the picture, John eats 1/16. His sister Gina had already eaten 5/16. So I could add to see that altogether they've eaten 6/16 of that cake. How much of the cake is left? Well, I know that I started with a whole cake, or they started with a whole cake, so they had 16/16. If they eat 6/16, they're still going to be left with 10/16, and then I would simplify again to get that same answer as we got with the picture. Okay, number 2 says how much greater is 13/15 than 5/12? Okay, so it's telling you that this one is the greater fraction. It's greater than this one. But to find the difference, we're going to use subtraction. So I'm going to think of our 4 square method with fractions. I have 13/15 minus 5/12. Okay, in the second box or second section, I think of the big M, which stands for the multiples. I want to list the multiples of 15 and 12 because I want to find a common denominator. So 15 plus 15 is 30, plus 15 is 45, 12 and 12 is 24, and then 36, 48. And I see that I don't have a common denominator yet, so I can just keep going. So 15 more than 45 would be 60, and 12 more than 48 would also be 60. So my common denominator is going to be 60. So I'm going to rewrite both fractions with 60 as my denominator. And then don't forget, I need to do the same thing to the top that I do to the bottom, or the same thing to the numerator as I do to the denominator. So 15 times 4 equals 60. So then 13 times 4, well, okay, that would be 52. And then same thing over here. I know that 12 times 5 gave me 60. So 5 times 5 is 25. And then I'm going to subtract those, and I'll get 27/60. And that's another one that you can simplify. I think I showed some of you this trick at one point, but if you add the digits, well, okay, first of all, I know I can't divide both of these numbers by 2 without having a remainder or a decimal. I can't evenly divide them by 2. So then I'm going to the next number. I'm thinking, okay, are they divisible by 3? If you add the digits, and that number is divisible by 3 without any remainders, that means the whole number is divisible by 3. So 2 plus 7 is 9. Well, I can say 9 divided by 3 without any leftovers. So I can say 27 divided by 3 without any leftovers. And then I'm going to do the same thing to my denominator. So 27 divided by 3 is going to equal 9, and 60 divided by 3 would be 20. So my answer is 9/20. Okay, Thursday number 1, my favorite order of operations. Okay, so we have this huge expression, but all we're going to do is make it smaller and smaller each time until we solve it. We're not changing the value. We're not making the value smaller. We're just making the problem smaller and easier to handle until we're down to the last operation. So remember, PEMDAS, P parentheses. I have brackets and I have parentheses, and they're all in the same category, but remember, I'm always going to work from the inside out. So I'm going to look at my innermost parentheses. I have 37 minus 14. And I know that 37 minus 14 should be 23. And then I'm just going to bring everything else down. I'm just going to rewrite it. I've already solved this part. Okay, it's really nerve-wracking to try to do math in your head on camera, so I keep double checking to make sure. But yes, 37, 27, yes. Okay, sorry. All right, so then I have this, and my brackets are still in the parentheses category. So that's going to be my next step, 23 plus 1, which is 24. Okay, so I've solved this part, and again, I'm just going to rewrite everything else. All right, so P parentheses, E exponents, there's no exponents. MD is multiply, divide, and please remember that it's whichever comes first in the problem out of those two operations. Multiply or divide, whichever comes first. So I have multiplication before I have my division, which means I'm going to multiply first. And 4 times 15 is 60. And then I'm just going to bring down everything else. Okay, I'm still going to multiply, divide for PEMDAS before I add and subtract. So the next step is going to be 24 divided by 2, which is 12. And then I bring down everything else. And then, of course, my last step is 60 plus 12, which equals 72. Okay, so my final answer for that one, there we go, 72. Okay, Thursday number 2. Last question. What is the sum of 8 and 995 thousandths and 144 and 6/10? The sum means the answer when I add. So I'm just going to add those two numbers. And the main thing when I'm adding and subtracting decimals is that I keep all the digits lined up and the decimals lined up. Okay, so I have my decimal here. I have a 4 in the ones place. I have a 4 in the tens place, and there's no tens place here, so I'm just going to represent that with a 0 or a placeholder. I have a 1 in the hundreds place, so I'm going to put a placeholder. And then I have a 6 in the tenths place, so it's lined up right underneath this tenths place. And then I can just put placeholders. The sum means I'm going to add. When I add and subtract decimals, I can bring that decimal straight down. 5 plus 0 is 5, 9 plus 0 is 9, 9 plus 6 is 15, 8, 9, 10, 11, 12, 13, 4, 5, and then 1. So my final answer is 153 and 595 thousandths. I hope this helped.